In April 2010, the Deepwater Horizon rig exploded in the northern Gulf of Mexico and started leaking oil. We wanted to try and understand where the oil from the oil spill might go, and to do this we used a very high-resolution global ocean model. We put a tracer, which was like a dye, like a food color, at the point where the oil was released, and then we did a large number of runs to explore possible pathways. As far as we know, this model we used is the only one in the world which is run on a global configuration with this kind of resolution and on a timescale of many decades. We've run it for over a century. The problem with trying to predict ocean currents on short timescales is it's like trying to predict the weather. Eddies can be thought of as the weather of the ocean. An eddy in the ocean is like a rotating circular vortex, and ocean eddies are chaotic and they're very difficult to predict. The only way out of the Gulf of Mexico is via this feature called the loop current. And the loop current sheds eddies sporadically every 6 to 19 months. No one can predict when they're going to shed. So the problem of predicting when and how fast anything is going to get from the northern Gulf into the Atlantic depends critically on these eddies. Matthew Maltrude was the person I collaborated with on this project. Matt's actually been a key developer of this model over the last decade or more, and he ran all the simulations, mostly on a DOE machine called Jaguar, one of the supercomputers there. DOE supercomputers were absolutely critical to this study. There's no way we could have done this research without them. And there are actually very few computers in the world where you could do this kind of simulation. If you had a single quad-core desktop, so a really powerful state-of-the-art desktop machine, it would take roughly 12,000 times longer to run these simulations than it did on the DOE supercomputers. I think that high-resolution models of both the atmosphere and ocean are really useful in situations like the oil spill and like the nuclear explosion we just saw, because they're the only quantitative tools we have that really allow us to assess the possible trajectories of these contaminants on a day-by-day or month-by-month timescale. Otherwise, it would just be guesswork. So they do have a very important role to play in understanding and educating people about where things might go and on what timescales.